Throughout history, cosmic catastrophes have fascinated and unsettled humanity. Stories of asteroid impacts, supernova explosions, and rogue black holes have fueled both scientific inquiry and popular imagination. These dramatic events remind us of the immense forces at play in the universe and our planet's vulnerability within it. While such scenarios often evoke fear or awe, it is important to approach them with a rational perspective. By examining the actual risks posed by astronomical phenomena, we can better understand their likelihood and potential impact. This balanced approach allows us to separate fact from fiction and appreciate the true nature of cosmic threats. Asteroid impacts have shaped Earth's history, with significant events leaving lasting marks on our planet. While large collisions are rare, smaller asteroids enter our atmosphere more frequently, often burning up before reaching the surface. Notable historical impacts, such as the one that contributed to the extinction of the dinosaurs, highlight the potential consequences of these cosmic encounters. Today, scientists use advanced telescopes and monitoring systems to track near-Earth objects, assessing their trajectories and potential risks. International collaborations and early warning networks help ensure that any threatening asteroids are detected well in advance. These ongoing efforts play a crucial role in safeguarding Earth from future large-scale impacts. Supernova explosions are the dramatic deaths of massive stars, releasing an immense amount of energy and light into space. These cosmic events occur when a star exhausts its nuclear fuel and collapses under its own gravity, often resulting in a powerful blast. Typically, supernovae take place thousands to millions of light-years away from Earth, far beyond the reach of their destructive effects. The vast distances involved mean that the radiation and shockwaves from a supernova dissipate long before they could impact our planet. For a supernova to pose any threat to Earth, it would need to happen within about 50 light-years, which is extremely rare. As a result, the odds of a supernova explosion directly affecting life on Earth are exceedingly low. Gamma-ray bursts are among the most energetic events in the universe, releasing intense beams of gamma radiation that can outshine entire galaxies for brief moments. These bursts typically originate from catastrophic cosmic events, such as the collapse of massive stars or the merging of neutron stars. The destructive potential of a gamma-ray burst is immense. If one were to occur close to Earth and be directed at our planet, it could strip away the ozone layer and disrupt life. However, the threat to Earth is considered negligible. Gamma-ray bursts are extremely rare, and the likelihood of one occurring nearby and aimed precisely at our planet is exceedingly low. Astronomers closely monitor these phenomena, but current evidence suggests that our planet is not in danger from gamma-ray bursts in the foreseeable future. Black holes have captured the imagination of many, often portrayed in popular culture as cosmic vacuum cleaners capable of devouring entire planets. In reality, black holes are regions of space where gravity is so intense that nothing, not even light, can escape. While they are indeed powerful, the idea of a rogue black hole suddenly appearing and swallowing Earth is extremely unlikely. Black holes do not wander the galaxy at random, and their gravitational influence diminishes rapidly with distance. The nearest known black hole is thousands of light-years away, posing no threat to our solar system. Scientific observations and models confirm that the probability of a black hole approaching Earth is virtually zero. Thus, while black holes remain fascinating objects for study, they are not a danger to our planet. Solar flares and coronal mass ejections are powerful bursts of energy and plasma from the sun that can impact Earth's environment. When these events occur, they can disrupt satellite communications, GPS systems, and even power grids due to the intense electromagnetic radiation and charged particles they release. Despite these technological challenges, the effects on human health and daily life are generally minimal, as Earth's atmosphere and magnetic field provide substantial protection. While solar storms can cause temporary inconveniences and require mitigation strategies for sensitive infrastructure, they do not pose an existential threat to humanity. Scientists continually monitor solar activity to predict and prepare for these events, ensuring that society remains resilient. Overall, solar flares and coronal mass ejections are fascinating natural phenomena that remind us of our planet's connection to the sun. But they are not a cause for alarm. The solar system is a remarkably stable arrangement of planets, each following its own predictable path around the Sun. Thanks to the laws of gravity and orbital mechanics, these planets maintain safe distances from one another, making sudden collisions virtually impossible. Over billions of years, their orbits have settled into a delicate balance, preventing chaotic interactions. While minor impacts, such as asteroids striking planets, do occur, the likelihood of two planets crashing into each other is astronomically low. This stability is a result of both the vast distances separating the planets and the precise speeds at which they travel. In essence, the solar system's architecture ensures that planetary collisions are not a threat we need to worry about. Alien invasions have long captured our imagination through countless books, movies, and television shows. These stories often depict hostile extraterrestrial forces threatening humanity, but such scenarios remain firmly in the realm of science fiction. To date, there is no credible scientific evidence supporting the existence of aggressive alien civilizations or their intent to invade Earth. Most searches for extraterrestrial life focus on detecting simple organisms or signals, rather than advanced societies with hostile motives. The vast distances between stars and the enormous challenges of interstellar travel further reduce the likelihood of any such encounters. While the possibility of life elsewhere in the universe continues to intrigue scientists, the idea of an imminent alien invasion is not supported by current scientific understanding. Vacuum decay is a concept from theoretical physics that describes a possible instability in the fabric of our universe. According to this idea, the universe could exist in a false vacuum state, which is not the most stable configuration possible. If a transition to a true vacuum were to occur, it could fundamentally alter the laws of physics, rendering the universe unrecognizable. However, scientists emphasize that the likelihood of vacuum decay happening anytime soon is extraordinarily low. Calculations suggest that such an event would require conditions or timescales far beyond anything we can imagine. As a result, vacuum decay remains a fascinating topic for physicists, but not a practical concern for our lifetimes or even the distant future. Billions of years from now, the Sun will exhaust the hydrogen fuel at its core, marking the beginning of its transformation. As the Sun ages, it will expand into a red giant, engulfing the inner planets and dramatically altering the solar system. Eventually, it will shed its outer layers, leaving behind a dense core known as a white dwarf. This process, though monumental, unfolds over such vast timescales that it poses no immediate threat to humanity. Our species, and perhaps even Earth itself, will likely have changed or moved on long before these cosmic events occur. For now, the Sun remains a stable source of energy, supporting life and shaping our daily existence. The distant fate of our star is a fascinating subject for scientific study, rather than a cause for present-day concern. Cosmic rays and space radiation are high-energy particles that originate from sources such as the Sun and distant galaxies. When these particles reach Earth, they pose potential risks to living organisms and electronic systems. Fortunately, our planet is equipped with two powerful shields: the atmosphere and the magnetic field. The atmosphere acts as a barrier, absorbing and scattering most incoming radiation before it can reach the surface. Meanwhile, the magnetic field deflects charged particles, guiding them away from populated regions. Together, these natural defenses ensure that the majority of harmful space radiation never reaches us, making Earth a safe haven in the vast expanse of space. Science plays a crucial role in identifying and addressing cosmic risks that could impact life on Earth. Astronomers use advanced telescopes and observation techniques to track asteroids, comets, and other celestial objects that might pose a threat. Space agencies such as NASA and the European Space Agency collaborate on missions designed to study and sometimes even alter the paths of potentially hazardous objects. Through continuous monitoring, researchers can provide early warnings and develop strategies to mitigate risks, such as deflection or evacuation plans. These efforts not only protect our planet, but also deepen our understanding of the universe and its dynamic nature. The ongoing work of scientists and engineers ensures that humanity remains vigilant and prepared for challenges from space. Cosmic catastrophes such as asteroid impacts or supernova explosions capture our imagination with their sheer scale and unpredictability. They remind us of the vastness of the universe and our place within it. However, the likelihood of these events affecting us in our lifetimes is extremely low. While it's natural to be curious about such dramatic possibilities, it's important not to let distant threats overshadow the real, manageable risks we face every day. By focusing our attention on issues like climate change, public health, and safety, we can make meaningful improvements in our lives and communities. In the end, understanding cosmic dangers can inspire awe, but practical action belongs here on Earth.